now the correct solution is indeed to put it right inside there, outside of the loop. Yeah?
Is there any way you can, like, so let's say the user puts in like -1 and then it like will print something like try again instead of like just repeating I demand that you give me a positive?
So you could. So if you wanted to have a more specific yelling at the user, like that is negative, I don't want that, or some kind of informative message, absolutely you could do it, but you'd have to redo this loop. The advantage of a do-while loop is that if you're content in just saying the same thing again and again, I mean, look how easy it is to do that. But the downside is you can't provide more informative messages like, that's 0, or that's negative. To do that, you're probably going to want to introduce some if conditions inside of the loop, and maybe even not use a do-while. Just use a while loop or a for loop, as we'll soon see, and yell at the user appropriately. Yeah?
Is there a way to destroy a variable within the scope of a program?
Good question. Is there a way to destroy a variable within the scope of a program? No, but we will have that feature in PHP. And back. Does n have a default value? Short answer is it depends. We'll come back to that before long. So for now, assume that if you do not give a variable a value, it's going to contain what we're going to call literally a garbage value. It's going to contain some unknown value. And indeed, that's the common case, for it to be some piece of junk, some random pattern of bits that just so happens to be there. Let's go here.
In your while condition, you had like many things, many categories, so if you want to just fit your variable.
OK.
Is there any limit on like the number of logical conjunctions that you can use?
Good question. Is there any limit on the number of logical conjunctions you can use in this parenthetical here? If you wanted to say while n is less than 1 or n is greater than, say, 99, if you want it to only be a digit from 1 through 99, no, you could keep oring things together, anding things together. You might want to use parentheses to make sure the logic is all correct. The only limit really is on readability and what a reasonable programmer would sort of be comfortable with or yell at you at if it's just becoming unwieldy, frankly. All right, yeah?
Within the same level of scope with the curly brackets, can you keep reinitializing a variable?
Yes. Within the confines of the curly braces, you could keep reassigning n a value in different lines of code again and again and again. That is perfectly correct. The only thing you don't want to do, as we discussed on Friday, is you don't want to redeclare that variable by saying int again. Once you've declared it, stick with it. Don't specify int on the left-hand side again. So here's a slight variant of this. So this is a version called positive2.c, and it's example now of introducing a Boolean variable. Bool is not a type in C that's built into C. It does exist in C++ and PHP and other languages, but the CS50 library gives you access to a Boolean data type that's just true or false in lowercase. And notice that just with this modification, you can actually make the code a little more readable, a little more like English. So at the top here, I've this time declared a Boolean called thankful, just because I want it to sound kind of cute and read like English. And I'm initializing that Boolean value to false. And again, false is in all lowercase. Then I've got a do loop, and I've got printf, I demand that you give me a positive integer. And now notice a difference in this program is I am getting an int from the user, but what am I doing with it? I mean, really nothing. I'm comparing it, so I'm kind of using it for something, but I'm throwing that value away as soon as that line of code is done executed. But in English, those two lines, if getInt greater than 0, thankful equals true, what's the implication? Well, it just means that this program is meant to be thankful when the user finally provides it with a positive number. Now, why is this useful? Because now in my while condition, inside of those parentheses down here, now we can introduce another piece of syntax, namely the equal sign, that says, well, while thankful is false, while I'm not thankful, do this loop again and again and again. We've seen Boolean expressions before. If you have a greater than sign or a less than sign, right, just logically, that's going to evaluate to a bool, true or false. X is less than Y, true or false, yes or no. Well, you can literally put a Boolean value there like thankful and compare it against a Boolean value like false or quote unquote true to express the exact same thing. But we can do this slightly more elegantly, but we should first tease apart this. Why am I doing equals equals instead of equals, do you think?
The equals equals compares the value of thankful that we get, which is the new value of thankful after it starts to reduce.
Exactly.
False, whereas when you say thankful equals to, it assigns the value to thankful.
Exactly. So if you think back to what single equal sign means, this is the so-called assignment operator. Now, I might keep saying equal sign, but in programming, this is the assignment operator, and it puts the value on the right into the thing on the left. Now, the problem is the world kind of painted itself into a corner, because the first time someone needed to write a program that needed to express the comparison of two values, where in English or in math we would say equals to compare two values, kind of out of luck, because we already used the equal sign on our keyboard to denote assignment of values from right to left. So the world decided that, well, fine, let's just put two equal signs. So equals equals does an actual comparison. Equals does a single assignment. So realize what could happen here. What if I accidentally do this? And this, too, is a very common mistake early on. This code will compile, but what's going to happen now? Exactly. This mistake, stupid as it is, this one character I made the mistake with my keyboard, is automatically, every time the while condition executes, it's going to assign to the variable called thankful what value? False, and then it's going to evaluate it. So again, just like in math, order of operations, the stuff inside the parentheses happens first, then the big parentheses themselves happen. So thankful gets a value of false. Then the question is asked, well, while false, well, what's going to happen then? Well, false is false, which means it's going to break out. So in other words, if you have while thankful gets false, this thing is never going to loop more than once, because no matter what the user does, as soon as you hit the while condition, thankful is going to get a value of false, and bam, the while loop's not going to repeat itself, because again, it only repeats if it is true. All right, so one last example here. Let me scroll down to, let's say, +3, just to introduce one more piece of syntax. For those who remember what the previous example looks like, what's the one difference in this program? Yeah, so there's this new piece of syntax, the exclamation point, otherwise known as bang in programming. And bang thankful here just means not thankful. It inverts the value of a Boolean expression. So I actually don't need to be so verbose. I don't need to say while thankful equals false. I can instead just say, more idiomatically, while not thankful. And that's how you would pronounce that, not thankful. And it just inverts whatever the thankful value is. So just logically now, you can read it quite easily. Do, print that, get an int from the user, while you're not thankful. And you're only going to become thankful when the user does what? Final sanity check? Gives you a positive integer. That's it. So again, 3 different ways this time that we've done something. But what's nice now is that we have the ability to express ourselves with just slightly new pieces of syntax. But these programs are somewhat underwhelming to run. Let's add something that's just a little graphical now. So here's one other example called progress. Progress1 actually introduces another header file and another function that you won't generally use, but it does hint at fancy features to come. Notice that because I read the manual, turns out I was told to include unistandard.h, that header file, if I want to use a function called sleep. And you can probably guess what sleep does. It puts the program to sleep for 1 second in this case. So what does this thing seem to do? Well, it's apparently going to simulate progress from 0 to 100%. So notice this is not a bug this time. In my for loop, I deliberately want to go from 0 to 100 because I want to count from 0 up through 100 in this case. And apparently, it's going to print on every iteration %complete, %d. That's an integer. We're going to plug in the value of y. And now this looks a little cryptic, but take a guess. Why do I have %d, %%? Yeah, exactly. So this is what we generally call escaping a character. Here, too, it's one of these painting yourselves into a corner. If you have decided as a world to use % to mean here comes a format code for printf, like %s, %d, %f, well, you're kind of out of luck if you want to actually say %, because the compiler apparently has been trained to know that anytime you see %, another letter is going to come after it. But if you want a literal %, the way of doing that is to say %%. Now you can imagine this actually becomes messy. How would you do %%? %, right? Or 3% is 6%, 4% is 8%. But thankfully, this is not a common case, right? Odds are this is not a common program to write, so the world just made a judgment call that fine, that might happen, but it's very rare. So what's this actually going to do? It's going to print 1 per line, once per second, this kind of progress bar. So let's try this. Let me open a bigger terminal window here so we can see more at once. And let me compile progress 1. It compiles OK. And again, to be clear, all I did was I opened the separate program that's called terminal. It's this little black icon there. And it just lets me do the same thing full screen, just so it's a little prettier. Enter. All right, so it's getting interesting, right? You can really see and feel this for loop. Frankly, I'm already getting a little bored, so why don't we go ahead and hit Control-C to kill this program. But let's assume that it's actually going to go up through 100, which it should, because according to the code, we have less than or equal to 100. But this is obviously not a very user-friendly progress bar, right? It'd be nice if just the number updated itself. But notice the takeaway here. Printf is pretty limited. Printf is kind of like an old school typewriter. Once you type out a word and do \n, enter, that's it. You can't really scroll back and change what you typed because it's already emblazoned on the page. So in this case here, it'd be nice to somehow more elegantly just change the % sign. So we can actually do that. Let me go ahead and open up version 2 of this, progress 2. Now it's a little fancier because I had to fix a bug, but notice the difference now. What am I actually using to print out the %? I'm not using \n. I'm instead using what? So %r. So this is one of these silly computer issues we'll actually trip over multiple times during the semester. Long story short, in the world of Unix and Linux, these older operating systems and modern operating systems that are mostly command line based, but just like the appliance, that nowadays do have graphical environments, the world decided that to end a line in a text file, in other words, when you hit enter, what actually goes in the file? Well, it was \n. Now, unfortunately, the folks at Microsoft decided years ago that when you hit enter on your keyboard, what actually gets saved in the file? It's not just \n. It's something called \r \n. So 2 characters get saved in the file. Those of you who actually remember typewriters might know that in a typewriter, the old mechanical thing, when you hit enter on the keyboard, not only does that roll, that scroller kind of scroll this way, also the printing head moves back to the left. So that's what Microsoft was being consistent with. \n moves the roll thing upwards, and carriage return, CR, \r, moves the head back to the left of the screen. So technically, Microsoft is kind of implementing the old school typewriter the most accurately. But then Apple came along and decided, to hell with you, we're only going to use \r. So we have 3 different operating systems, major operating systems, 3 different ways. And this is thankfully mostly irrelevant, except when you try to open a file that you created on a Mac on a PC, a text file, or when you open a file on a PC that you created on a Mac, or a Unix or a Linux machine. If you've ever opened a text file, on Windows in particular, with notepad.exe, and even though it's supposed to be a lot of text, it's all on one crazy long line, that's simply because Notepad expects \r \n, and if it doesn't see it, which it might not if you made it on a Linux computer or a Mac, with all together, you're just going to get some big mess. WordPad, by contrast, if familiar, knows about just \n. So long story short, we'll come back to that with web programming.